Hi, welcome back to my channel Maths with Armin. This is another video on probability. In this video, I'm going to look at the basic probability concepts. Please, if you have not yet subscribed to my channel Maths with Armin, please subscribe. I do hope you will enjoy this video. This video is going to consist of an overview of basic probability concepts with some examples. Then at the end of the video, like with all my videos, there'll be an exercise worksheet. Let's start with the overview. We're going to look at the concept of probability, sample space, events, and outcomes. Then we're going to look at some basic probability rules, and then the concept of complementary events, and then the concepts of and, or. What is probability? It is the mathematics of chance that enable us to predict the likelihood or foretell the likelihood of certain occurrences or happenings, and indicates the relative frequency with which we expect an event to occur. Briefly stated, probability is the chance that an event will occur. And to calculate the probability, we will have the total number of favorable outcomes divided by the total number of possible outcomes. Now let's look at the definition of some of the terms we've actually used here. An experiment is the act of making an observation, right? So if you do you observe tossing a coin or flipping a die, rolling a die. For example, you flip a coin and you record whether the side is facing heads. So that is an experiment, right? You flip a coin and you keep a record of, is it landing heads up or whether it's heading tails up. An outcome. What is an outcome? One of the possible things that can occur as a result of an experiment. So if you look at the flipping of a coin, what could the outcome be? That's right. It can either land up heads or it can land face up tails. In other words, there are two possible outcomes in the coin tossing experiment. What do I understand by sample space? It is the entire set of possible outcomes, right? For example, in a single coin flipping experiment, so in other words, when we flip a coin, the sample space can be heads, tails, right? So that is the sample space. What do we mean by an event? Event is any subset of the sample space, right? For example, if we have heads facing up, so the event would be head facing up. We could also have the heads not facing up. Now, next we're going to look at some probability rules. And the first rule here is that the probability of an event occurring is always a real number between 0 and 1. In other words, the probability will be a value somewhere between 0 and 1, with both the 0 and the 1 included. So, for example, a probability of 0 means that the event will never occur. And if I have a probability of 1, that means that the event will always or definitely will occur. And a probability of 0,5 means the event is expected to occur 50% of the times. Let's continue here. Probability value can be expressed as, there's three ways we can express it. We can express it as a common fraction, or a decimal fraction, or a percentage. Please note, a probability should not and cannot be represented as a ratio, right? Only as a common fraction, only as a decimal, or as a percentage. Now, the greater the probability, the more likely the event is to occur. What does that mean? Let's illustrate that by means of an example. There is an 80% probability that it will be raining tomorrow. So it's very likely that it will rain. Conversely, we can state that the smaller the probability, the less likely the event is to occur. In an example,
there is a 10% probability that there will be load shedding this week. So it's not likely that there will be load shedding.
Okay. Now let's consider the sample space if we toss a fair six-sided die, right? So it's a die with six sides. There's the die there. You can see there's six sides, a 1, a 2, a 3, a 4, a 5, and a 6. And what will the sample space be? It can be a 1, and it can be a 2, a 3, a 4, a 5, and a 6. So that's my sample space. A 1, a 2, a 3, a 4, a 5, and a 6. Now we want to look at the sample space of tossing two fair six-sided dice. So there I've got the two dice, green one, and you see they're changing color. So let's just use these two dice here. So this one here, there are 6 possible outcomes that can match with the 6 outcomes there. So that sample space will be 6 times 6, and 6 times 6 is 36. So there's a total of 36 outcomes there. Let's illustrate that. It'll be much easier illustrating them, the actual ones there. So this is the first die and the second die, the first die and the second die, the first die and the second die. And so you can have a 1, 1, you can have a 1, 2, and you can go through all of them. There I've got a 5, 4, and there I've got a 4, 2. Okay. We can also represent it this way. Instead of dots, you can use actual numbers there. And I've color coded them. I'm using a white die and a green die. So there'll be the white and a white with a green, and a white with a green, and a white with a green. Okay. Now notice here that there I have a 2, 4. So it's a white, 2 on the white and a 4 on the green. But 2, 4, there's also a 2 and a 4 somewhere else there, but they're not the same. Can you see? You see this 2 is for the white one, and that 2 was for the green. So 2, 4 and 4, 2 is not the same. Now let's go back to my actual dies there. There's my sample space that I have. And this is the sample space we're going to use for toss, if we toss two fair six-sided die. Now let's look at an example here where we want to toss two fair six-sided dice, right? But we want to roll 2 4s. So what's the probability of getting 2 4s? There we have 2 dice being tossed, and we want to see what would be the outcome here should be 2 4s. Now let's just look at the sample space there. Where do you see 2 4s? That's the only place where there's 2 4s, right? So that's the sample space. The total number of outcomes is 36, and there's only one. What's our definition of probability? The number of favorable outcomes divided by the number of possible outcomes. The possible outcomes is a total of 36, and the favorable outcome in this case there is only one. So in other words, the probability of getting 2 4s would be that's the only outcome we have, and these are all the possible outcomes. Now if we numerize that, that's going to be 1 over 36. So the probability of rolling 2 4s would be 1 over 36. Now let's look at another example. In this case, we want to get 2 even numbers, right? So I need to look at my sample space, and I need to identify where I get 2 even numbers, right? You see the 2 even numbers? That's correct. So I want to find the probability of getting 2 evens. So let's look at the 2 evens. Where do you see the 2 evens? That's where I have 2 evens. That's a 2 2 and a 2 4 and a 2 6 and a 4 2. Those are all. And how many are there? If you count them, you see there's exactly 9. So that's 9 over 36, and we'd like to simplify that, and that's going to be 1 over 4. But we can leave it as 9 over 6 in the meantime. Now let's again take toss 2 fair die, but we want to look at the probability of rolling at least 1 2. What do we mean by at least 1 2? In other words, there must be a 2, and there could be the other dice could also have a 2. So that's our sample space. So if we want the probability of at least 1 2, let's follow. Where do you see at least 1 2? That's correct. Those are the cases where I've got a 2. I even have a case where I have another 2. That's 2 2. Okay, those are all the 2's are here, and all the other 2's are there. So how many are there altogether? We count them, we see it's exactly 11. So the probability is 11 over the total number of outcomes is 36. You can also represent the sample space using a tree diagram. So let's consider the case where we flip a fair coin twice. So there's the coin. So if we flip it once, the first flip, it can either be heads or it can be tails, right? And the probability of getting a head is 1 over 2 or 0,5. Probability of getting a tail is also 0,5. Now for the second flip, so if I have heads, then the next could be that I can get heads again, or I can get a tail. And the same with the other one, it can be heads or tails, right? And the probability again of a heads is 0,5 and tail is 0,5. Let's list the outcomes. So after flipping it a coin twice, we can have, as you can see there, we can have, just follow the color, heads and heads there. And then we have heads and tail. And then we can have tails and heads. And then we can have tails and tails. So those are the 4 outcomes that you can have. Let's calculate the probability. The probability of a head is 0,5, right? So those are the outcomes there. And the probability of getting heads and heads is 0,5 times 0,5, and we calculate that should be 0,25. The same way we can calculate heads and tails. It's 0,5 times 0,5. Tails and heads, 0,5 times 0,5. Tails and tails, 0,5 times 0,5. And you can see the sum of that, that's exactly 1. It's important that we understand the difference between the concepts of event and outcome. An event is a subset of the sample space, right? For example, if we take the probability of getting a desired number, so the event there would be getting a number, for example, less than 3, right? So the event would be getting a number less than 3. The outcome relative to this, an outcome is the result of an event. So what would the result be of getting a number less than 3? So the results could be either getting a 1 or getting a 2. So those would be the outcomes there. Now we're going to do an example to illustrate that the sum of probabilities of all outcomes must always be equal to 1. Let's take the example of flipping a fair coin. So if we have a coin, it can either land heads or tails. So the probability of getting a head would be 1 over 2, which is 0,5. Probability of getting a tail, which is 0,5. Those are the only outcomes. So if we take the sum of those outcomes, we get a total of 1. Let us consider another example to illustrate that the sum of probabilities of all outcomes must always be equal to 1. Let's consider the case of flipping 2 fair coins. So there we have our 2 coins. So we can have probability of heads and heads, which is 0,25. The probability of getting a heads or a tail is 0,25. Probability of getting tails and heads is 0,25. Probability of getting both tails 0,25. We find the sum of those probabilities. I get a total of 1. 0,25 plus 0,25 plus 0,25 plus 0,25 is equal to 1. So the sum of probabilities of all the outcomes must always be equal to 1. Now we're going to consider an example where we're going to illustrate the events in sample space, and we're going to use a Venn diagram to do that. Let's take the example of tossing a fair 6-sided die, and there you can see a die tossing there. What is the sample space? 1, 2, 3, 4, 5, and 6, right? Then consider the event of getting an even number. So what would the outcomes be here? The outcomes would be, that's correct, a 2, a 4, and a 6. Those are the even numbers I can get tossing a fair die. And event number B is getting a prime number. What's a prime number? The prime numbers we can get here is 2, 3, and 5. But what do you notice about those outcomes of those 2 events? That's correct, we've got a common outcome of 2. So if we represent A with that circle, that magenta circle, and we represent the B with this aqua blue, so the common 2 would be where they overlap, and that's where the 2 the outcome 2 would fit in there. Then we can complete the rest of event A. You can put the outcomes there. That's still missing is 4 and 6, and the outcome there for B would be 3 and 5. But the sample space consisted of 6 there. So there's one more. That's correct. One more. That's the one that needs to go there. Now let's consider the probability of getting an A and B. What do we mean by A and B? That means the probability of getting an even number that's prime, right? So which of these even numbers are prime? That's correct. That's the common one. What color is that? That's the green color. That's the AND part. So this is the AND part of the two circles that I have there for my Venn diagram. And that represents the AND there. So there's only one outcome, so it's 1 over 6. That's only the 2, so that's 1 over 6. Now we also want to consider A or B. So that, what does that mean? It is getting an even number or a prime number. So it can be there, it can be the even numbers, or it can be a prime number. So it's all of, that's correct, it's all of these numbers here. Outcome can be 4, a 6, a 2, a 3, or a 5. And how many are there? There are 5, so the probability there is 5 over 6. Now let's consider another rule here, the complement rule. The probability that an event does not occur, right? So if you want to find the probability of an event that does not occur, it will be equal to 1 minus the probability that the event will occur, right? So then we can express this here. So the probability of an event not occurring, we can write this probability of A prime, or you can even say probability of A's complement. There are different ways to write it. Sometimes you can even put a little probability of A bar, but generally we say probability of A prime. That means not A. And how do we do that? It's 1 minus the probability of A occurring, right? So if you know what the probability of A is, it's just 1 minus that probability, which will give you the probability of the complement. And this we refer to as the complement. There, the complement of A. Consider an example. We want to determine the probability of not getting two tails if two fair coins are flipped. So let's look at the sample space and the outcomes. So those are the 4 outcomes we can have. You can have heads, heads, or heads, tails, or tails, heads, or tails, tails. And these are the associated probabilities that we previously calculated as well. So if I want the probability of not an event not occurring, it's 1 minus the probability of the event occurring. So let's take our specific example. Probability of not getting two tails is 1 minus the probability of getting two tails. So 1 minus, what's the probability of getting two tails? We see there, it's 0.25. So that's 0.25, and simple arithmetic, 0.75. We could also have just looked at the opposite there. Those are the cases where you are not getting two tails. So it's actually the probability of not getting two tails is the sum of probability of getting two heads, getting a head and a tail, or a tail and a head. And getting that sum, 0.25 plus 0.25 plus 0.25 is exactly also 0.75. Right? So you can either do it with 1 minus, or you can just find the sum of the other probabilities there. Now let's consider the third rule, the probability of two events happening together or one event after another event. So the probability of A and B, which can also be denoted as A intersection B, that is the probability of the one event times the probability of the second event, right? And here, because we have the probability, the product of the two probabilities of the one event and the other event, we refer to this as the product rule. What is essential here is the term and that we use, A and B, which that and can also be denoted as intersection, right? So A and B would then be the probability of the one event times the probability of the second event. It's important to note here that events A and B have to be independent. We will talk about more about independent events a bit later.
Now, let's look at the example of flipping a fair coin twice. So there we have one coin, and then we're going to toss it the second time. Okay, so the chance of getting a head twice is if the probability of getting a head is 1 over 2 or 0,5, then the probability of getting a head and then thereafter another head, so the probability of head would be the probability of head times the probability of getting a head. And what's the probability of getting a head? 0,5. And so it's 0,5 times 0,5, and calculating that we get 0,25. 0,25 being 25%, so the chances of getting ahead twice is 25%.
Now let's just consider one more rule. This will be the rule of determining the probability of one event or another event occurring. So the probability of event A or B, which we can also write as probability of A union B. Now, when we're going to have or, probability of one event or another event, we're going to use the sum rule. Now, this will only apply if the two events are mutually exclusive events. So the rule would then be probability of A or B is the probability of A plus the probability of B. Thus, the probability of the first event, and now we add to it the probability of the second event. So if I have probability of A or B, it's the probability of A plus the probability of B. And that is the sum rule. Now let's consider an example of applying the sum rule. So we're going to look at the case where two six-sided dice are tossed. Event A would be a sum greater than 9. Event B would be getting at least 1, 2. So let's get our sample space. There's our sample space. Consists of 6 times 6, which is 36. So let's look at the case where we have probability of a sum greater than 9. Where do we see a sum greater than 9? Let's look. That's where we get a sum greater than 9. So the probability there would be 6 over 36. Let's look at the other one. We want at least 1, 2. Let's see, where do we have at least 1, 2? That's where we have at least 1, 2. And if we count that, the probability there would be 11 over 36. But if we look at those two events, we see those two events are mutually exclusive. So the probability of A or B is the probability of A plus the probability of B. What is the probability of A? Let's do the substitution. Probability of A is 6 over 36, so substitute the 6 over 36. Probability of B is 11 over 36, so we substitute 11 over 36. We do that calculation, we get 17 over 36. Now let's come to the most important part here, and this is the exercise worksheet for you now to practice. I've taken questions from previous external question papers and I've referenced them. Some of the questions I've slightly adapted. Let's look at some of the questions. Here's a question about two fair six-sided die. Question number 2. We've got a question here where you have to know the concept of that the sum of the probabilities is equal to 1. Question number 3. Here we've got a question here where probabilities are given. Question number 4, we again have a question on two fair six-sided die. Question number 5, we have a question here where the number of boys is missing and you have to calculate the number of boys based on the given probabilities. Question number 6, we have the number of orange balls missing and we have to calculate the number of orange balls. The solutions will be found at the end of the worksheet. I hope you enjoyed this video on the different probability concepts. There are also other videos on probability that I've prepared.
such as probabilities on mutually exclusive events, video on independent events, on the use of Venn diagrams, use of tree diagrams, use of contingency tables. There are also many other videos on grade 10 to 12 CAPS mathematics video topics. Please, if you have not yet subscribed to my channel, please subscribe. And until next time, hope you enjoy Maths with Amin. Here are the solutions to the 6 examples in the exercise worksheet. Here are the solutions to question number 1. You may pause and then you can try it on your own. Here are the solutions to question number 2. You may pause and try it on your own. Here are the solutions to question number 3. Pause and maybe try it first. Here are the solutions to question number 4. Here are the solutions to question number 5. Here are the solutions to question number 6. I hope you enjoyed this video on the different probability concepts. There are also other videos on probability that I've prepared, such as probabilities on mutually exclusive events, video on independent events, on the use of Venn diagrams, use of tree diagrams, use of contingency tables. There are also many other videos on grade 10 to 12 CAPS mathematics video topics. Please, if you have not yet subscribed to my channel, please subscribe. And until next time, hope you enjoy Maths with Amin.